Hello everyone. In this video I am going to show you how to draw shear force and bending moment diagram, and this is the example 3. First we have to know our sign convention. In this video I am going to use this sign convention, that is, I will consider shear force clockwise positive and bending moment sagging positive. This is my beam and you can see it labeled as A, C and B. A to C there is a distributed load of 2 Newton per meter and overall beam length is 20 meters. A to C length is 10 meter and C to B length is 10 meters. And at A there is a pin support and at B there is a roller support. So I am going to draw shear force and bending moment diagram on these axes. First we have to draw free body diagram. So this is the free body diagram. So here I have to mark support reactions. At A there is a pin support, so I mark 2 force components, one horizontal force component and one vertical force component. At B there is a roll support, so I mark one vertical force component as By. So here I mark these forces as Ax and Ay at A. At B I marked it as By. I can't work this distributed load like this, so therefore I marked it here as resultant force. Magnitude of distributed load is 2 Newton per meter and acting length is 10 meters, therefore I can mark resultant force as 10 times 2, 20 Newton, and it is acted middle of this AC part, so length of this AC part is 10 meters, so it acted 5 meter from point A and 5 meter from point C. So now I can find these support reactions. So for that I will consider sum of all the vertical forces. So then I can get Ax equals 0 because there are no horizontal forces other than this Ax force. Next I am going to take the moment about A to the counterclockwise direction for AB. That means this entire beam. When I take moments, I will have By times 20, that means By is this force and 20 is the distance to By, minus 20 Newton. 20 Newton is this force and distance to 20 Newton force is 5, and this minus sign because moment due to this 20 Newton force is clockwise direction, so I consider counterclockwise direction. When I simplify this I can get By equals 5 Newton. Next I am going to take sum of all the vertical forces. So if I take vertical forces I will have to write Ay plus By minus 20 Newton. This force is acted downward, and now I already know value of By. I can substitute it here as 5 Newton. So I will have Ay plus 5 Newton minus 20 Newton. Then I can simplify this and get Ay equals 15 Newton. Now I can draw the complete free body diagram. So you can see these are the forces which I found before. Now I am going to draw shear force and bending moment diagram. For that I am going to cut this beam. I will cut this beam like this, so I can mark the distance as x. So this is the beam which I cut, and I can redraw it, and I can mark distributed load over this small part of beam, and this is the support reaction of A, and this is the shear force of this location, so I marked it as V1 downward, and this is the bending moment, I marked it as M1. And please keep in mind, I marked this beam as sagging moment and this V1 as clockwise moment. If you take moment of V1 about A, it gives clockwise moment, right? So I can mark this length as X. So you can see here also I marked the length as X. Here also I can't deal with this distributed load as like this. So I have to write the resultant force of this distributed load. So this is the resultant force. Magnitude of distributed load is 2 and this length is X. So resultant force is 2X, and this force is acted middle of this small part of beam. Length of this beam is X, so it is acted middle of the beam, so that is X over 2. Now I can find this V1 force, so I can get 15 minus 2x minus V1 equals 0, and I can get the answer for V1 as V1 equals minus 2x plus 15. So this is the range. This equation is valid 0 to 10. So that means beyond 10 I can't apply this equation. So this is a graph paper. This is our equation, V1 equals minus 2x plus 15. So it's like y equals minus mx plus c. So this is a function, right? Not equation. This is function. It's like y equals minus mx plus c. So I can draw it like this, and this point I can mark as C. So this is the shear force diagram shape, right? So now I have to find the starting point and ending point of this shear force diagram. For that, this is our range. For I will find V1 when x equals 0, then I will find V1 when x equals 10. So when x equals 0, V1 equals 15, and x equals 10, V1 equals minus 5. So you can find it by substituting these values to this function, right? So now I can draw shear force diagram. So you can see here. So this is the starting point, it's 15, and ending point is minus 5. So this is the shear force diagram, and units are Newton, right? This is Newton per meter, so that means these units are Newton. Next I am going to find the M1. For that I am going to take the moment about point A. Here I mark the equation of this line, and it's V1 equals minus 2x plus 15. And when I take moment about A, I will have to write M1 minus V1x minus 2x times x over 2 equals 0. So here I can substitute this equation for this V1. So when I substitute it, I can write it like this, and when I simplify this equation, I can get M1 equals minus x squared plus 15x. And here also range is 0 to 10. So this is graph paper. This is my function M1 equals minus x squared plus 15x. So it's like y equals minus ax squared plus bx. So it's like this. So you can see it's a curve, and here also I have to find the starting point and ending point. For that I will find M1 when x equals 0, it's M1 equals 0, and when x equals 10, M1 equals 50. and also I have to find maximum or minimum. So here is a important theory. So it says bending moment is minimum or maximum when shear force is 0. Bending moment is minimum or maximum when shear force is 0. That means maximum or minimum point is lay on this point. That means if I draw a line like this, minimum or maximum point lay on this shaded line or this dash line. So if I draw bending moment diagram for this AC part, I can draw it like this. This is the ending point and starting point is 0, and it's like this. So you can see here there is a maximum point and it is lay on this dash line, right? But we can't keep it as it is. We have to find this maximum value. For that I have to find this length, so I will mark it as simple L. So using this triangle, right, this line is v1 equals 2x, actually v1 equals minus 2x plus 15. So I can get a slope of this line using this equation. So it says slope is minus 2. Let's say 2. We will consider numerical values because we are going to find the length. So no point of considering minus values. So slope is 2. So slope equals 15 over L. So I can write it like this. 2 equals 15 over L. 2 is the slope. So now I can find value of L. L equals 7.5. So this L equals 7.5 means this length also 7.5. So I can mark it right here, 7.5. Now I can substitute 7.5 to this M1 equation. Then I can get this maximum bending moment value. So if I substitute x equals 7.5, I can get mx equals 56.25 Newton meters, right? So I can mark it right here. This is the maximum bending moment. So that's it. So I completely draw shear force and bending moment diagram for this AC part. Next, only left is this CB part. So for that I am going to cut the beam like this and mark this length as x from this point A. So I can redraw it, and this is the point A and this is the cutting point. So I can mark shear force as V2 this time and bending moment as M2. Now I just have to find V2 and M2. Here also this is a distributor load, so I will consider resultant force of this distributor load as before. So this length is x, and this is the free body diagram of this diagram, and this 20 Newton is the resultant force of this distributor load. It came from 2 times 10, right? Okay, now I'm going to find V2. For that I will consider sum of all the vertical forces. When I consider vertical forces, I can write 15 minus 20 minus V2 equals 0, and it comes V2 equals minus 5 Newton. And as you can see, this is a constant, right? So it's like, and please keep in mind here range is 10 to 20, right? It's valid in this region, 10 to 20, and it's like y equals minus c. That means it's like this. It's the shear force. Next I'm going to find the M2. For that I am going to take the moment about A, and when I take moments I can write V2 minus M2 minus V2x minus 20 times 5. So I already know value of V2, so I substitute it here minus 5. So when I simplify this I can get M2 equals minus 5x plus 100. So range is 10 to 20, and it's like y equals minus mx plus c. So this graph is a straight line. So I have to find the starting point c equals 10, and I will find m2 when x equals 20. So when x equals 10, m2 equals 50, and when x equals 20, m2 equals 0. So now I can draw bending moment diagram here. So it's like this. So this is the complete shear force and bending moment diagram.